Yes. Good morning, dear student. Today we will discuss unions. I hope you all have attended the structures class. So, just continuation of the same, rather, right? We'll continue user defined data types. Yes. So, structures. Structure, as we said, it's a derived data type. It is a user defined data type. It's a variable to hold one piece of information or to maintain the records, we said, rather, right? uh, Arrays can hold the information of the same type, whereas the structures will hold the information of different kind. One way, if I say the arrays are homogeneous, then structures are said to be the heterogeneous data kind, right? So with to maintain the records, as I said, right, of employees, student, or inventory record, sales record, and all kind of thing. So a structure is a collection of variables of different data, as I said, right? And all together are going to be pointed to a single name called a structure name. So it's a user-defined data type, as we know, right? The syntax, if you see, right, the syntax of structure is, struct is the keyword with the help of which you probably, declare a structure. Struct followed by a space, blank space, and then followed by the structure name you give, rather, right? So the structure name, for example, if you are maintaining the regards for a student for which you want to create a structure, then how do you do that? Struct space student, and then let us say it is having certain fields: name, roll number, address, and age. Fine. Age is an unsigned. What is the difference between assigned and unsigned? Unsigned is having values from zero onwards. It doesn't have the negative values, rather, right? So anyway, when you probably declare a structure of student and a variable, if you create like s1 at the time of declaration, before you terminate with a semicolon, if you give a variable immediately after the closing brace, a variable will be created. You can create any number of variable at the time of definition, like this, okay? S1 comma s2 comma s3, so on up to s4, whatever, semicolon. That way also you can probably, here what we did is we have created one variable of the same student kind. So for s1, memory will be allocated. Generally, memory will be allocated for the variables, as we know, right? So this S1 consists of how many variable, how many fields here. Name is one field which is carrying a 20 character. Each character requires 1 byte, so it's going to be 20 bytes. So if let us say the base address starts with 4,000, then 20 bytes, will be 4001 till up to 4019. So next 4020 is the first byte address of the roll number. Roll number is an integer, so it requires 2 bytes. So 4020, and then address carrying 20 characters, so 20 bytes it requires. Each character 1 byte requires. So 4021, you know, to 20 is actually, yeah. This is 4040. This is right, and this is 4042. Age is an integer kind, okay, which also requires 2 bytes. Fine. So you can see this is how when a variable is created of a structure kind, then the memory will be allocated based on the requirement that has been already decided by the language designer, rather, right? So, if, for example, you want to implement one student, record information. In order to maintain the one record information of a student, then you need to first create a variable of that particular student structure kind. So this student structure kind is having about two fields. One is name and roll number. So we can see here we have created a variable, and when we are reading the data of this particular student, how do you access the members of this particular student with the help of membership operator called dot, right? So stu is the variable. So stu, okay, stu dot, we say the members. If I have to access u dot name, I should use to access name. Yeah, to access a roll number, I should say stu dot roll, right? So that's how you do it. You have read while reading the string, you don't give any ampersand, but while for others, you need to give this ampersand here, right? This is missed here. Anyway, so the same when you're printing like this, okay? So this programs we have done it before, of course, rather, right? How to declare a structure, how to create a variable of that kind, and read the members for that particular structure using that particular variable which we have created, rather, right? So another thing that we have discussed, while discussing the structures, you can have the members of a structure as an array, rather, right? And you can have array of structures. So array of structures are also we have decided. For example, if you want to maintain the records of student for 60 students, right? Then what do? The first you define the student structure with the help of struct keyword here, struct space followed by the student name. Then you have the members of this particular student structure defined like name, roll number, and percentage. Then in the main, okay, when you are implementing, for example, for 60 students, then I have to create an array of this particular student kind structure with 60 size, rather, right? So struct space student space s of 60. When I say, then an array of 60 elements is going to be created, right? And each element carries how many members? Name, roll number, and percentage, right? Name, roll number, and percentage, like this, okay? So that's how exactly, when created, and you want to read the members of structure for all this particular student. You want to read the information of all the student. Then how do you access each of the element? With the help of indexing mechanism, rather, right? So this element, the first element is going to be pointed with s of 0, second is going to be s of 1, like that till up to s of 59, okay? So you, in order to access the first student record, and read some information into it, rather, right? S of 0 dot, you say name, s of 0 dot roll number, and s of 0 dot percentage, right? But if you have to read all 60 students, then you'll be taking a for loop here. You can see there's a for loop we have taken. So then you're going to read all these details. Since name is a string here, form specifier required is percentages, roll number is an integer, so percentage D is required, percentage of marks is float, so percentage F. So within double quotes after scanf, you'll be giving the first percentage, then double quote comma, you want to specify the variable into which the values have to be read. Name is a string, so you don't give ampersand here. S of I dot name, where I is going to be varied between 1 to 60, rather, right? So if it is 1 to 60, then first one is going to be 1, second one is going to be 2, like that, and the last one is going to be 60. See, in C, we are given the index value to start from anywhere. Rather, you can start with 0, you can start with -1, you can start with 1 as well. So here we have started with 1. If we start with 1, then probably for 60 records, the last index of the last record value will be 60, right? So that way you can probably do that. If you start with 0, it will be 59. So then you don't have equal here, rather, right? You just say less than 60. Okay. So you're going to read all this data, then you're going to print the details of the same with the help of the for loop here. You can see while you're printing, again, you're going to specify the function specifier first, and after the double quote comma, the values which you want in place of those function specifiers, you're going to specify the variables. So again, the data which is going to be here printed from each of this particular record. So you're better taking the for loop here, and with I being varied between 1 to 60, you're going to print the details of all 60 records here, right? So this is an array of structure. You can point, you can have a pointer to a structure, right? You can have a pointer to a structure. If I have a book kind structure, right, which carries name and author, these are the two strings, and then we have page number is an integer. So I have, let us say, declared a variable of book. At the time of declaration, you can initialize like this, right, using flower braces. If you have multiple values, then you'll be using flower braces. Even for array and structures, at the time of declaration, you can initialize with the help of this kind of mechanism, rather, right? So immediately after you declare the variable equal, within braces, you will specify the values for each of the members in the order they are mentioned in the particular structure, rather, right? So here name, the first one goes to name client, the second one author is the title, right? First one is C language, actually. First one is a book name. Book name is nothing but C language. Then book author is title, and page number, which page number you want, right? Let us say 300 page number. So this is the book. Then what happens for B, memory is going to be allocated based on the members. Like here we have name, we have author, we have page number, right? So name, actually it is a character array, so carrying about 20 characters. So it's a string of 20 characters and 20 characters, and you have 22, 22, 42, 42 bytes of memory going to be allocated for B here. And you can see here the values of the members are being initialized at the time of declaration itself. C language is the name, and author is title. So then you set 300 as a page number. At the time of declaration, you have initialized the member values as well, rather, right? Now, you have taken a pointer P, right? This pointer has to point to, let us say, B. Then what is that you have to do is you'll have to say that P equal to ampersand B. Then what happens? This pointer, which is of course book kind, but then it is pointing to this particular entire structure. Now, in order to access any of the member from this particular structure with the help of pointer, how do you access the help of membership operator? In pointers also we have discussed, right? While we were discussing the pointer with structures, we have discussed all this, right? The members of the structure with the help of pointer, when you're accessing, you access with the help of dereferencing operator. P in direction, C, sorry, name, right? That is name. Another member you have P in direction author, okay? P in direction page number, like that you can probably access. So when you are accessing the same, you are accessing the printing, you can see here you can print it directly with the help of B. When you're accessing with the help of B, you just say B dot name, rather, right? B dot name, that's what exactly you said here. You can see, listen, B dot name, B dot author, B dot, this is with the help of structure you are printing. This is with the help of, you know pointer you are printing. With the help of pointer, when you're printing, you're using the dereferencing operator, you can see, right? That is arrow that you get by pressing hyphen and greater than value, right? So this is how probably structure with pointers you can implement. The advantage of having used the pointer, as we have discussed in the pointer class, you can go for more detail the pointer class video, rather, right? And coming to self-referential structure, right? A member of a structure pointing itself is said to be the self-referential structure. Okay, like look at here, student structure carrying what name? Name is one member, and another member you have here is B. B is a DOB kind. What is DOB? DOB is a structure. See, DOB is a structure having three fields: date, month, year. Okay, these are the three members you have for DOB, rather, right? So when you have defined student, another structure, in this structure you have the member B. You can see the member B is having, is again a structure kind, is again a structure kind. This is said to be structure within a structure. The member of a structure is said to be the structure itself, then it is said to be nested structure, right? So nested structure is a structure within a structure, or the member of a structure is again a structure. You can see B, which is a member of student, which is again a structure of DOB kind, right? So when you are trying to access the B members, how do you access? Well, first of all, you need to create a variable of student kind. Here you have created S is a member. So for S, memory is going to be allocated. How much memory is going to be allocated for S based on its member? How many members you have? Name is one member. So name is basically character array of 20 bytes, so 20 bytes of memory will be allocated. Then B is a structure kind, right, of DOB kind. So where again it is having how many fields? It is having three fields: D, M, and Y. So each of them are integers. So for each of them, 2 bytes each is going to be allocated. So it's going to be six. So total 26 bytes of memory being allocated. Now, if I have to read the data for this particular student record S, right? So S dot name, S dot with S dot name you can read the name, but the date of birth, when you are reading, you need to read these members, all these members, right, separately. So how do you access these members? Through B, that is B dot D. But how do you access this B? With the help of S. So how do you access all these members? That is with the help of double dot. You can see S dot B, then B dot D, right? So when you say S dot B, you come here first, right? This is S. This entire thing is actually created for what is. Now when you say just S dot B, you come here first. Okay, and then when you say b dot d, you come here. Similarly, if you want to access m, then how to access s dot b dot m? You have to access here, then s dot b dot y. So that's how exactly, with the help of this double dot, rather, you can see the nested structure members are being read with the help of this s, right? So s dot b dot a, s dot b dot m, s dot b dot y. And similarly, when you're printing, also you'll be doing the same thing, right? This is called nested structure, right? I hope this is clear to all of you. You can probably pass the entire structure to a function. Okay, you can see how we have passed the entire array as an argument to a function before, right? We have seen when we have worked with function with arrays, right? And of course, binary search, linear search, and sorting mechanisms we have implemented using functions, taking array as an argument, rather, right? So similarly, you can have the entire structure to be passed as an argument to the function. Fine, and you can probably return the same from the function, right? So here in this particular example, if you're looking at this particular structure, student structure, which is having about three members: name, roll number, percentage, and you're taking a variable of this kind s, and then display. This is a function wherein you are displaying all the members. What are they? Name, roll number, and float, which of them are string, integer, float respectively, so that you have defined declared as argument for display function. Then you are reading the details with the help of this s, which you have created all these members: name, roll number, and percentage. And now you are calling display function by passing the read details for this particular s, right? So you can see s dot name is basically an array, character array, right? And then rule number is an integer, and percentage is float, rather, right? So you have defined the display function here. After the display function when called, the values which you have read that has been passed as an argument will be passed to this particular formal arguments, and then from there these particular string copy and these statements are going to be, when executed, you are going to get these values which have been passed as argument to this particular display function are being taken into the local variables of this particular function, and then the same will be printed, rather, right? See, this is structure members we are passing, but then if you want to pass the entire structure also, you can rather pass. Fine. You can see here in this example, we are passing the entire structure. See, display, the same example is repeated. In the previous example, structure member separately has been passed as argument to the function. But whereas here in this particular example, we are passing the entire structure as an argument, you can see. This is also possible, rather, right? The same student structure you can see here. You have created a variable of that kind, and now the prototype of the function you have mentioned here, right? If you are defining the function source code after the main function, you need to specify the prototype the same before you call it in the main, rather, right? So this is nothing but the prototype the same, because you're calling in the main here somewhere, rather, right? So since the code is not before the main, so you have to give the prototype. This is prototype, right? Prototype is something like specifying the compiler that this kind of function is available, so that the compiler will look for it, search for such kind of function when a call is made for the same, rather, right? So you can see here, after you read the member details of this s student, name, roll number, and percentage, that entire structure here you are passing, that entire s you're passing to the display. So you can see in display function you have that structure as an argument. So what exactly does the argument values? These are set to be what? Actual variable. This is set to be the form variable. When the actual variable is passed to the form variable during the function call, that the actual value is extracted into this formal, and then from formal it goes into the local, rather, right? Or the local values which are extracted from this formal are going to be rather printed here. The same thing you can see here. When you execute it, you will see the output. This output is going to be printed from the function, rather, right? Okay, I hope this is clear to all of you. Now you can have a structure within a structure into another structure. Like for example, struct A is there, in which you have one member called number, and then you have a string name. You have a variable called s. You have created two variable of this A, E2 comma E3. Now, when you are declaring, this particular structure variables, E1 equal to, you are specifying the values for the same at the time of initialization. See, the declaration of the structure variables you can do immediately at the declaration definition part itself. This is said to be definition, right? Defining the structure. How do you define the struct followed by the structure name? Then within flower braces, you will now mention all the members and terminate with the semicolon. Before termination, before you terminate with the semicolon, if you specify the variables, then those variables are going to be rather created immediately after the structure been declared, right? So, but then if you want to create one more variable, you can create another variable after the structure definition, and at the time of declaring a variable, you can rather initialize as well, like this. Okay, so you can copy the data from one particular structure to another structure. That's how copying you can do it with the help of string copy function for strings. See, you have three members: number, name, and s. So even data you want to copy in E2. So just say even dot E2 dot E number equal to even dot E number. It means even dot E number was actually A. So that is going to be now initialized to A2 dot E number. So E2 number also A. Similarly, even dot name is copied in E2 dot name with the help of string copy function. Similarly, its S value can be copied. So then what happens? E2 becomes a duplicate of E1. It means a copy of E1 is generated with the help of E2 rather, right? This how you can, and this is one way of copying from one structure to another structure using member wise. You can copy each member of a structure into its corresponding member of the another structure, right? This is one way of copying the members of a structure into another structure. But then you can rather, the second method is you can directly copy the structure like this, with the help of assignment operator. You can just say E3 equal to an E1. When I say just say E3 equal to E1, like how even each of the member of E1 is copied into the corresponding members of E2 has done here before in the first method. Similarly, in second method also will happen. When you just say E3 equal to, it means you can using assignment operator you can copy the structure values from one to another rather, right? So when you print the same, you'll get the copies of E1 itself, right, in E2 and E3. So this is how you can copy the structure from one to another with member wise, or you can directly copy with the help of variable using structure variable rather, right? Just using the assignment operator, you can just say E2 equal to, even if I say where even it both are structure variables, so this assignment operator will work as a copy operator between them rather, right? Now coming to union. Union is another kind of user defined data type. We say it is very similar to structure. If you look at from the characteristic point of view, very similar. Like how you declare a structure in a very similar fashion, you declare a union with the help of union keyword rather, right? For example, if I have to create a employee a union, right? Union space employee emp. Then inside that you can have certain variables of that kind, character x and character float y. Like how you create a structure, similarly you create union. What all the characteristics that we have that we have discussed, right? That all being applicable to union, because it's a user defined data type, and it's carrying the different kind of data elements, heterogeneous data type only. You can say the members of the same you can access with the help of membership operator called dot. Like if I am creating a variable of union kind E, then how do I access the members of this employee? That is E dot X. Like how when I have to access the members of a structure with the help of structure variable, I use the same membership operator called dot E dot C. Very similar here also I'll be using. But what is the main difference here? If you probably look at, is from memory point of view rather, right? You see, unions are conceptually similar to structure. Syntax of union is very similar as that of structure. We have seen the only difference in terms of storage. In structure, each memory has its own storage location. For example, if I have this characteristic float y, for each of the members, separate memory is going to be allocated. For example, character requires 1 byte and it's not an array, so just 1 byte of memory will be allocated for C here, right? But for y, if this is x, let us say x or whatever. So for X, and then for Y is a float. So float requires 4 bytes. 4 bytes of memory being allocated, right? Separately, the memory is going to be allocated for each other member of the structure. But what happens for union is when you are creating a variable of union kind for E, the memory is going to be allocated. If you see, for example, here, the amount of memory required for the largest data member in that particular union is going to be allocated. The same is going to be shared, by all the members. It means that, here character x, character float y, you have character x requires how many byte? 1 byte, and float y requires how many byte? 4 byte. So what is the largest memory that is required for any of the data members of the particular union is nothing but 4 bytes. So only 4 bytes of memory been allocated, you can see, and the same is going to be shared by both this x and y. So when x is using the same. So when x is using, probably y cannot use the same data, right? But when y is using, because when y is using, the other can, as not it is able to use, because that's being occupied by y data, right? So that's how the when memory sharing is being done, simultaneous access cannot be possible, right? That's what exactly what we are saying is all members of union use a simple shared memory location which is equivalent to the size of its largest data member. So simultaneous access is not possible. I hope you understand that, right? So this is what exactly the difference between the unit. If I, let us say for example, I have x of 20, okay, character, this particular character is an array, let us say, then 20 bytes of memory going to be allocated, rather. How many bytes? 20 bytes, not 4 bytes. And the same is going to be used by both x and y. When x is using, y cannot use, and when y is using, x cannot use, right? For example, if I have a union of, let us say, one integer and one character, one float, then this requires 2 bytes, this requires 1 byte, this requires 4 bytes. Out of which, who is occupying the highest memory? Float. So 4 bytes of memory is going to be allocated. The same is going to be shared by all this, integer, character, and as well the float. So when one is using, one is accessing, the other cannot access, because the other one is using, the previous one will be simply replaced with the new one. Yes or no? When A is using, A's value will be there. When B is using, A will be replaced with B. It means A value will be vanished. That's how exactly simultaneous access is not possible, is it? But when you want to read and print, then probably you, after read, immediately you print the same and then go for the new reading of the other member of the particular union. That's how exactly the union concept differ from structure. Otherwise, it is very similar to structure. It's in terms of syntax and accessing the members, declaring the union variable, and initializing its members, and reading, printing, all that are going to be very same. Only difference is nothing but is this, right? Memory is going to be allocated only for one of its largest member. The same is going to be shared by all the members of the particular union, right? I hope this is clear to all of you. Any doubts?